Hi, in this video we're going to look at algebraic terminology. Now, algebra is using letters to represent unknown values. So for example, this x here is an unknown value, the y here is an unknown value, and we'll see what they're called. And algebra is specifically using letters to represent unknown values, and we hope that there might be some kind of information that allows us to work out what each of these letters are worth. Now, let's look at these terms here. We've got variable, we've got term, we've got constant, we've got expression, we've got equation, we've got formula. So this is really important vocabulary to do with algebra, and we'll explore each of these words in turn. So let's start with variable. A variable is just like a letter in algebra. So for example, this x here, that's an example of a variable. The y is an example of a variable. The m is an example of a variable. And let's put these examples here. We've got like x, y, could be a, etc. We're using a single letter to represent a value. That is a variable. And specifically the word variable, that sounds a bit like vary. So it is a letter used to represent something that could potentially vary. It could be different values. So that's a variable. That's the first one. What about term? Now, a term is basically some numbers and variables, some numbers and letters kind of together in one to form a term. So, for example, like the 2y here, that is a term. 2y actually means two lots of y. We'll explore that in future videos. Even the whole of the MC squared, that is a term because it's a collection of letters and possibly numbers together, maybe with powers. But we wouldn't consider the x plus 2y to be a term because it's separated by that addition. Similarly, the y minus 3, that wouldn't be a term because it's separated by the subtraction. So basically, it's some numbers and letters without an addition or subtraction, that kind of thing. So some examples of terms, we've got like 2x, for example, 4y. It could be like xy squared, for example, etc. And actually, it's possible for a variable to be a term. So, for example, we can see the x here. The x here is obviously a variable, but it's acting like a term because it's just a collection of one thing, basically. So a variable can itself just be a term if it's on its own. So if you don't have 2x or xy, that kind of thing. Okay, so that's a term. Now, a constant, this one's a bit more complicated. Usually when we refer to a constant, it's like when we have like a constant term. So it's a term that doesn't have any variables in it. So for example, this 5 here, that's a constant, and constant just means it's fixed in value, it can't change. So the 5's been fixed in value, so that would be an example of a constant. The minus 3 here as well, that's also an example of a constant. So let's put some examples. It could be things like 5, it could be like 3, it could be minus 2. These are different constants. We can even have things like pi. You might have seen pi before. It has the value of 3.14. Now, it seems a bit weird because we are using a letter, was a Greek letter, to represent a value. But the point is that the value can't change. So this is where it gets a bit confusing because constants can actually involve letters, which is confusing because didn't we say that when we have letters, that's a variable, right? But if we know that we've got a letter to represent a value that can't change, so we then say it's a constant because constant means it's not changing. Variable means it's varying, right? So that's a bit confusing, but certainly if you have like a number on its own, that's going to be a constant. Right, the next one is expression. Now, expression is just a collection of terms, maybe added or subtracted together. So, for example, we got 2x as a term, y is a term, minus 3 is a term, and they're being sort of added and subtracted together as a collection of terms to overall form an expression. So, some examples of expressions, we've got like x plus 2y, that would be an expression. You could have 3 minus 4. That would be an expression, for example. Just examples of expressions where you've got pluses and minuses in between the terms, basically. So those expressions. What about an equation? Now, an equation is when you have an equals. So can you see we've got an equals here? So this whole thing is an equation. You've got an equals here. So this whole thing is an equation. X plus 2y equals 5 would be an equation. And if you've got a single equals here, you can have something to the left of the equals and something to the right of the equals. And we'll see what an equation means in later videos. So examples of equations, you could have like x plus 2y equals 4. You could have x squared plus x minus 6 equals 0. That would be an equation. It's got an equals in there. Now, a formula is a kind of special kind of equation. It's still an equation, but it's a special kind of equation where you only have a single variable to the left of the equals. So we got equals here. We've only got a single variable, a single letter to the left of the equals, and then we call that equation a formula. And I'll explain what I mean by formula in terms of how we understand it. But just some examples of formulas. We might have, for example, v equals u plus at. That's a formula because it's an equation. It has an equals, but there's a single letter, single variable on the left-hand side. Or another one, we might have, for example, the E equals mc squared. That's an example of a formula. It's a very famous formula in physics, E equals mc squared. Einstein came up with that one. Right, okay, so we've got all our terminology here. Now, how do we understand a formula? Why is it called a formula? What makes it different from an equation? Let's just say that I have a formula for working out how much I'm going to charge someone based on the number of hours I've worked. It might be the cost, C, so let's say C is the cost. The cost is equal to, let's say, 20 multiplied by h, where h is the hours worked, plus 10. So basically, this is a formula saying that the price I charge, the cost, is going to be equal to 20 lots of the number of hours. So if it was, for example, 3 hours, it'd be 20 times 3 hours plus 10. And this is a formula because it allows us to work out a particular quantity, just one quantity. So it allows us to work out the cost in this case. I can work out the cost based on other stuff. So that's why it's convenient to have like the C on its own on one side of the equation, because I can work out then the cost based on other things. That's why we call it a formula. Now let's finish by just doing a few more examples. Right, we've got this thing here. Is that an equation, expression, or a formula? Well, it has an equals, so it's either an equation or a formula, but we don't have a single variable on the left of the equals, so it's going to be an equation. What about the next one? This thing here. Well, we've got a collection of terms. 8y is a term, 4y squared is a term, 6y cubed is a term, and we've got a collection of terms. We called that an expression, didn't we? So this is an expression. Next one. We've got an equals here. So because of the equals, it's going to be an equation or formula. But we do have a single variable on the left of the equals. So that's going to be a formula. And this formula we'll see later, it's the area of a circle. So it allows us to work out the area of a circle based on the radius of the circle. We'll explore these terms later. What about the next one? Well, it's got an equals. So it's going to be an equation or a formula. But we don't have just a single variable on its own on the left because you've got that 8 there as well. So this is going to be an equation. This one here, we've got an equals again. And you do have a single variable or a single letter on the left of the equals. So that is a formula. And then what is the variable in this expression? Well, the variable is the letter. It's that x there. So the answer is x. And then write down the value of the constant in this expression. Remember, an expression is a collection of terms. So the 6z is a term, the 9 is a term. But if the term is just a number, nothing else, then we call that a constant term, or a constant for short. So the 9 is the constant here. And what about this? Write down the number of terms in an expression. Well, the x is a term, the 10 is a term, and they're being added together. We can see there's 2 terms here, so the answer is 2.